Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at solving quadratic inequalities. Now in the last video, we had a look at linear inequalities and what they meant and how we can solve them. Today we're going to have a look at quadratic inequalities. Now we've dealt with quadratics before, but I'm going to introduce you again to the general form of a quadratic. Now the general form of a quadratic is quite simple. It is this: ax squared plus bx plus c. And with a quadratic, we input values of x. A, b and c are all the coefficients. A is the coefficient of x squared, b is the coefficient of x, and then c is just a constant on the end. So we've seen that general form before. It's quite easy for us to deal with that. And what I mean by quadratic inequalities is a quadratic, we've dealt when they're equal to something, equal to 0, and we can solve them. What I mean here is when they are maybe less than 0, or greater than 0, or, less than or equal to a linear equation, and we can do some manipulation in order to solve the quadratic inequality. So, what I'm going to do is I'm going to run through the method very quickly of how we solve quadratic inequalities, and then we will have a look at some examples. So, the first thing we want to do, I think there's 4 steps under this box. The first one is to rearrange so that the right-hand side of the inequality is equal to 0. So you'll have an inequality, you'll have something, a quadratic, in this form. You want to get the right-hand side here equal to 0. Okay, and you can do that by adding and subtracting things to both sides. Once you've done that, you then want to solve the quadratic that you've got. You want to solve that to find the roots. Now to find the roots, you set the quadratic, I'll write that as quad, you set the quadratic equal to 0. So you'll have a quadratic in this form, ax squared plus bx plus c. Once you've rearranged, set that quadratic equal to 0 to find the roots. And remember, the roots are just where the quadratic equals 0, where we cross the x-axis. Okay, so once you've done that, then what you want to do is sketch the quadratic. And we've done quite a lot of quadratic sketching, so we know how to do that. You should hopefully be confident with that. If not, you can watch some other videos. So that's the third step. So let's just recap a minute. We rearrange to get the right-hand side equal to 0. We then set it equal to 0, or sorry, not equal to 0 here. We want the right-hand side to be 0. Then set it to 0. Then solve for your roots, and then you can use those roots to sketch the quadratic. Then once you've done that, you can use your sketch to basically get the required values. You're not really solving, you're just looking at the graph and seeing the values that you need. And remember, this is an inequality. When we solved linear inequalities, we had a set of values because there's an infinite number of numbers that are less than 1, for example. So if that was x is less than 1 as your solution, then you've got many values. So that's why we're trying to still find the set of values. Okay, so I just want to quickly have a look at sketching and at step 4 here. How can we use our sketch to help us? It's all well and good me telling you that that's what you do, but how can you actually use your sketch to help you? Well, let's take this example here. Let's say our quadratic, I've just called it f of x here. Let's say the quadratic is this: x squared minus 4x minus 5. We want to sketch that, so we're going to set it equal to 0, and here it does factorise nicely, so we can factorise like that, and then we can set it equal to 0 to give us our roots, okay? And under here, we should, there we go, have our roots, okay? Either bracket can be equal to 0 here, so we get x is minus 1 or x is 5, and those are the 2 roots. And it's got a positive a, x squared is positive, it's just 1, so we get this positive U-shaped quadratic, okay? So what if, for example, this quadratic, let's have a look at the first example here, is greater than 0? Okay, so we've got our general form, we've got a quadratic, and we want to know the values of x that make this quadratic greater than 0. Well, in that case, that would be these parts of the graph. And actually, I think under this box, I should have, yes, I do. Perfect, look at that. I don't even need to draw it in. I can slide it along there. It's that part of the graph, okay? This green part here. The reason for that is because we want the quadratic to be greater than 0. So in other words, we want every part of the graph that is above the x-axis. We want it to be greater than 0. So where is f of x greater than 0? It's along these green parts of the graph there, okay? Then, well, you might ask, what happens if we are less than 0? So in this example, we've got x squared minus 4x minus 5 again, and we want it where it's less than 0. Well, there's only one bit of the graph now that we haven't coloured in. I can delete that box now, and we can see, if I drag that over, it is that part of the graph there. And that's because we want it less than 0, so we want to be below the x-axis, okay? Because you can think about it, if we're less than 0, this is the f of x axis. Here, all our values are negative. We are less than 0. And again, here, all of these are, well, we're on the positive f of x axis if we work across here, and we want f of x, which is our quadratic, to be greater than 0, okay? So actually, if we got solutions to that, well, we would say the quadratic is greater than 0 at these green points. So it's where x is greater than 5, because this is x at 5 here. So it's anything you can see, the green kind of goes past the x. It's all of this part of the green bit here. And of course, this carries on forever like that, okay? You know, we'll continue off the screen. So we can see that x is greater than 5 will give us where the graph is greater than 0. And also, x is less than minus 1. We can see this x part here being less than minus 1 gives us a positive value for f of x. So there, and I should really say here, or x is less than minus 1. That would be the answer to that inequality, okay? And here we can see, I always remember this, that the graph is connected. The graph is connected on this red part here. And so when we've got less than, and we've got this positive quadratic, here our answer is going to be connected. We're going to get just one inequality as our answer. And it's going to be minus 1 is less than x, which is less than 5. Because our two extreme values here is minus 1 and 5, and along the red here is the sort of solution to this quadratic on the graph, and so as an inequality, it's that inequality there, okay? So hopefully that makes some sense. Once you actually do this manipulation in parts 1, 2 and 3, you get to part 4 and you're going to do something like this. Okay, so let's have a look at an example. We are asked to find the set of values of x for which 3 minus 5x minus 2x squared is less than 0. So pause and have a go if you want to, and then press play and we'll work through the answer. Okay, hopefully you've paused and had a go. Let's see whether your answer is correct. The first thing I'm going to do is, well, I'm going to kind of compare it to my general form of a quadratic, and just out of habit, I always like to have x squared first. So I'm going to do a little bit of rearranging. Everything is kind of going to stay the same. I'm just going to write the left-hand side in a different order. I'm going to have, and I'll put a little arrow to structure my work in, minus 2x squared minus 5x plus 3 is less than 0. So all I've done is just written those three terms in a different order. Right, the first thing I want to do is, well, I want to get the right-hand side to be 0, and in this example, it already is 0. So that's perfect. Step 1 is already complete. And in fact, I'll write it in orange. Step 1, right-hand side equal to 0. And that's done already. Step 2, if we just go back and have a look, we wanted to solve the quadratic. And I added on here, to solve it, we want to find the roots, so we set the quadratic equal to 0. So, set it equal to 0, so solve. We want minus 2x squared minus 5x plus 3 to be equal to 0. Now, this quadratic does factorise, so always see whether it factorises first. If it doesn't factorise, then maybe try the quadratic formula. So factorising, I need two numbers that times to give me -6 and add to give me -5. Or is it +5? No, -5. Yes, -5. Okay, so I'm going to put my answers down here. So all my two numbers that times to give me -6, let's write down the factors of -6. 1 and -6, that times to give me -6, and it adds to give me -5. So we're going to use that as our answer. So let's do a green tick here. That is what we want. Okay, so I'm going to factorise this, and oh, actually, what I might do here is, before I do that, I might multiply everything by -1. You might have done this, and I didn't spot that actually. That might help me. Let's do that first, actually. So I'm going to multiply by -1. I did just look on my solutions and think something was different there. We had a +5, and this is the reason why. You could have continued like that, but I've just spotted that it's easier to multiply by -1. So if I just do that quickly, I'm going to get that. And the reason, ooh, that's a negative. The reason I do that is so I've got a positive at the start. And now we can carry on with what I was trying to do. I can say two numbers that times to give me -6, and perfect adds to give me 5. Okay, so yes, you could have done the way I was just about to do, but I find it easier to have a positive x squared. So again, factors of -6, that's 1 and -6. Now in this case, they do multiply to give me -6, but they don't add to give me +5. They add to give me -5. So what I need to do is I need to put the sign with the -1. So just switch it round. They still multiply to give me -6, and they add now to give me 5. So those are the pairs of numbers that I'm going to use. So factorising will give me 2x minus 1 and 2x plus 6 will be equal to 0. And then I'm going to divide this bracket by 2 to give me 2x minus 1 times x plus 3 is equal to 0. Now, if you're a little bit unsure of how to factorise that or what I've done here, have a look at my video on factorising quadratics. So what we can do now is we can just solve for our two values of x. So when I do that, I'll get x is 1/2 or x is minus 3. 1/2 from this bracket being equal to 0 and -3 from this bracket being equal to 0. Okay, so I've solved it, and then these are, and I'll write it here, these are the roots of the quadratic. So those are the two values of x at which we cross the x-axis. Okay, well, what is part 3? We want to sketch the quadratic, and that's quite easy because we know the roots. So part 3 is a sketch. So if I draw myself an x and y axis, we've got it here like that, and I'm just going to move that up a little bit, so we've got it kind of in the middle there, and this is my x, and then this is my, is it y equals? Well, it's not really, so we'll just put y equals there. Okay, so there's my x and y axis, and we had, originally, we had this, we had a negative quadratic, okay? Where is it? Up here. We had a negative quadratic. And so I'm going to have an N-shaped, okay? And we can see the roots are 1/2 and -3. So I'll put those on the graph, and we'll just move the x-axis over a little bit like that. Here we've got 1/2, it will be about there. It's just a sketch, it's just to help you do this solution, so don't worry about it being perfect. And then about there will be -3, okay? Now, again, it's going to be negative because that was the original quadratic that we had in the question. That's what we're trying to find the set of values for it to be less than 0. And so, what I'm going to have is a quadratic that kind of looks something like, and if I just do that, it's going to look something like that. And in fact, I will change that to be orange, okay? So that is y equals minus 2x squared minus 5x plus 3, okay? Right, so now what I want to do is, well, that's part 4. I want to use the sketch to find the set of values of x. So, to do that, well, we want where the graph in the question, look here, where the graph is less than 0. So what we're going to want, like I said previously, is those two parts of the graph, because we want the bits less than 0, where y is negative. We want these parts here, or in other words, the parts that are under the x-axis. So we can see that because the graph, or the grey parts of the graph, is not connected, we're going to have two separate sets, two separate inequalities as our answer. We're going to have, I'll just write it here, we're going to have x being less than -3, or x being greater than 1/2. Those there are your two inequalities as your answer. Because we can see for this here, if we work along the x-axis, if we get more negative going that way, we can see we need to be less than 3 for our graph here to kind of go along that way and be less than 0. And here, we need our graph to go that way to be more sort of greater than 1/2. And here we can see that part is going to be greater than 1/2, and that's the bit that we need. Okay, so those are our two inequalities as our answer. And that is all we have to do to solve the set of values for x for when the graph is less than 0. Okay, example 2, pause and have a go if you want to, and then we will work through the answer. Alright, part A says find the set of values of x for which 12 plus 4x is greater than x squared. And then B says hence find the set of values for x for which 12 plus 4x is greater than x squared and 5x minus 3 is greater than 2. So we had a look in the last video at how we can merge two linear inequalities together and get an answer that satisfies both. Here, we've got a quadratic and we've got a linear. But first of all, let's just have a look at part A. So, the set of values for x for which 12 plus 4x is greater than x squared. Now, we, in part 1, want to get the right-hand side equal to 0. I won't write down the title headings here, we'll just work through the answer. So, I'm going to minus x squared from both sides, just like an equation. I can do that. So I'm going to have minus x squared, we'll have a little arrow to structure my work in, minus x squared plus 4x plus 12 will be greater than 0. And then I don't want a negative x squared, I'm going to multiply everything by minus 1. And when I did that up here, did I get, oh no, that's fine, okay, we had an equals. Alright, let's set it equal to 0 first of all, so this, set it equal to 0 for part 2. I'll write that down as part 1, and I'll write this down as part 2. Equal to 0. Just structure my work in a little bit better. And then that will tell me, there's a little arrow, sort of telling me this is the next thing I'm going to do. We're going to multiply everything by minus 1. So I'm going to get x squared minus 4x minus 12 is equal to 0. Right, now what I want to do is I want to solve that quadratic. Okay, so solving that quadratic is going to give me this. Well, it factorises nicely. It factorises to give me that, and we'll just take it straight from the solution here. Okay, so that solution there, and then I can say, right, well, the two roots of that quadratic are x equals minus 2, or x is equal to 6. Okay, so those are my two roots. And again, I'll write roots. Right, part 3 then wanted me to do this. So part 3 wanted me to sketch. So if we do a sketch of the graph, it was originally, well, we're looking for this graph being greater than 0. And so it's a negative graph here. So it's going to be, well, let's put our roots on first. Minus 2 and positive 6. It's a negative, so it's going to be an N-shaped. And we'll draw it in orange again. It's going to look something like that. Okay, maybe a little bit better than that if we straighten it up. we want it to cross through those 2 points, like something like that. Can't get it to cross perfectly. There we go. It should look something like that. Okay, now it's not perfect, it just has to kind of give us an idea of what we need to do, and I should probably put X and Y on my axes there. Now, in the original question, we wanted our graph to be greater than 0, so we want this part of the graph there. Okay, that greyed out part there. Now, that is connected. There's only kind of one greyed area. Here, we have 2 greyed areas and they're not connected. The graph continues down here and down there, and they're never going to connect. This is how I think of it. So we have 2 inequalities as our answer. Here, we're just going to have one nice inequality, and our extreme values are our 2 roots, so 6 and -2. So this is part 4 here, really. We've got -2 is less than something, which is less than 6, and that something is x, because that's what we're wanting to solve. Okay, -2 is less than x, which is less than 6. And we can see that here. If I put a value there, don't know what that value will be, but it's on our grade part of the graph, it satisfies this inequality, because we can see it's less than x just by looking at the graph, and again by looking at the graph, it's greater than -2. So that is our answer. Okay, I think we also have another example. We do, so let's have a go at that example. Now, be careful with this one. We're being asked to find the set of values for which 6 over x is greater than 2. And we're told just one thing about x. We're told that it cannot be 0. And we need to be careful because we cannot multiply both sides of this inequality by x. Now, pause and have a think why. Even if you don't answer the question, just have a pause and think, why can I not multiply both sides of this inequality by x and then do part 1, get the right hand side equal to 0? Why can we not do that? We don't need to multiply by x, we need to multiply by something else. So have a think. Pause the video and have a go, and then we'll work through the answer. Okay, hopefully you've paused. The reason we can't multiply both sides by x is because we're only told that x is not 0. So x could then be positive or negative. Now, what happens when we multiply by a negative number? If we multiply here, both sides by x, x could be negative, this inequality will flip. Because whenever we multiply something or both sides by a negative number, the inequality will change sign. So we can't do that because x could be positive or it could be negative, we don't know. We can't take for granted that it is positive. So, well, if x is positive or negative, so x could be, all right here, positive or negative, that's shorthand for positive or negative. What is always going to be positive if x is that case? Well, it's x squared. X squared will always be positive because any number squared is always positive. So it's always going to be greater than 0. So in other words, positive. So the first thing I'm going to do is I'm going to take my inequality, which is that, and I'm going to multiply both sides by x squared. So when we do that, I'm going to get 6x is greater than 2x squared. Okay, so then we can just do part 1. We can get the right hand side equal to 0. So minus 2x squared plus 6x will be greater than 0. So the right hand side is now 0. And then what I can do is I can solve that inequality. So minus 2x squared plus 6x is equal to 0, and let's find the roots. Multiply both sides by minus 1 to give me 2x squared plus minus 6x is equal to 0. And then what we'll do is we'll then factorise. We can factorise quite simply here by taking out an x. If I factorise x out, we'll have 2x minus 6 is equal to 0. And then just be careful here. What I don't want you to do is do this. I don't want you to do that and then divide by x, because even though we're told in the question x is not 0, it's just a bad habit to do that, because in some cases x could be 0. So factorise normally here, just factorise out by taking an x. So that then tells me that x is equal to 0, or we've got 2x minus 6 is equal to 0, so x is equal to 3. Okay, so those are my roots here, and then what we've got is part 3 that tells me, well, what was part 3? We need to sketch that. So if we just do a sketch, yeah, we're in the black one, let's sketch it. So it's going to be, well, is it a positive or negative quadratic? All we did was multiplied by x squared and then took it over, so it's a negative quadratic here. And we've got roots at 0 and 3. In fact, even though x told me it was 0, not 0 here, you wouldn't have been able to do the other method, because what you would have done is got rid of our solution of x being 0, because you can't divide by 0 both sides, and then you would have only found one root, and that wouldn't help you. Okay, so factorise out your x like I did, and then we get 0 and 3. And again, it is a negative quadratic when it is greater than 0. So it's nice that all 3 examples have been negative. You could also say from that 2x squared minus 6x is less than 0. And then we would have had a positive quadratic. It doesn't matter either way. I'll go with the question and I won't multiply by -1 there. So I'll get a negative quadratic. So 0 and 3. And then I'm going to have something that looks like that. And you can see there, that's just a rough sketch. It just gives me the idea. I want where it is greater than 0. So I want this part of the graph. So hopefully now you get used to saying that is that inequality. Our two extremes, and x has to lie between those extremes. It's not equal to on our inequalities here because the graph cannot be equal to 0. If we did in our question have, if we had in our question that, then it has to kind of match in your answer. You have to have equals there. But just for my examples, we didn't have equals. Okay, so let's get rid of those equals.